Hi everyone! Today we're going to be looking at rate laws and how to determine the rate law based off the information provided in a table. There are a couple ways to do this. One is to just look at the table and not use any algebra to determine the order. And one is to look at it and use algebra to determine the order. So we're going to look at both ways because I think that depending on what the numbers are for the concentrations and initial rates, sometimes it's not so easy just to look at the graph and determine the order. So we're going to look at both ways, like I said, because they're both important to understand. So the first thing we're going to do is look at one concentration by itself, and we're going to look at the nitric oxide in this case. And nitric oxide, we can see undergoes a change in concentration between runs 1 and 2. And so that is a really good place to start comparing the runs 1 and 2 versus comparing 2 and 3 where there is no change in the concentration. The other thing we want to keep in mind when choosing which runs to compare is making sure that they are consecutive because it's more foolproof, if you will, and it's much easier to understand. So instead of 1 and 3, we're going to choose 1 and 2. So between 1 and 2, we can see that the concentration is doubling. And we don't want to stop there. We want to see, well, what's happening to the rate? And when we compare runs 1 and 2, we can see the initial rate changes from 0.05 to 0.1, which again is doubling. Now, when the concentration is doing the same thing that the initial rate is doing, we can determine that that's first order. So we therefore have just identified that nitric oxide is first order. When we look at hydrogen gas, we're going to look at runs 2 and 3 because there's a change there. And we can see that between 0.1 and 0.3, the concentration has tripled. We can see the same thing is happening for the initial rate, and it too is tripling. So that lets us know that hydrogen gas is first order as well. So that's one way to determine the rate law. Another way is to dive a little bit deeper into each component and use some algebra to determine what the order is, and that's what we're going to do now. So we're going to start with nitric oxide. And remember, we were comparing runs 1 and 2 for nitric oxide. And we're going to do our second run or final run over our initial run or run 1. And we're going to raise that to our variable, which is, in this case is the order because we have yet to determine that. And then we're going to set it equal to the same difference in the initial rate, and so we'll have run 2 over run 1 again. Then we will solve for what's in the brackets, and we will determine that we have 2 raised to the power of x equals 2. From there, we'll want to isolate our variable, and we'll plug log 2 over log 2 into our calculator and determine that we have first order. We will do the exact same thing for hydrogen gas, of course this time using runs 2 and 3. We will plug that all into the calculator, rearrange the equation, and find out that in fact hydrogen gas is 2 first order. And when we write this out, we write rate equals K, and then we've got our 2 concentrations or components. And you can see that we don't raise, nitric oxide or hydrogen gas to the power of 1. In chemistry, we just omit this one. It's redundant. But if you had determined that one of them was to the second order, you would, in fact, raise it to the power of 2. Or if you had determined one of them was 0th order, you would actually exclude whichever component had been determined to be at 0th order. So, for example, if we had determined that nitric oxide was 0th order, our rate law would be rate equals K hydrogen gas, and you wouldn't even see the nitric oxide. So I hope that kind of gives you a better idea as to how to determine rate law, and it gives you a couple ways in which you can do so. Thanks so much. Cheers.